In the second part of this video on exceptions, we will explain how to throw exceptions and how to define custom exception classes. First, let's examine the remaining syntax involving exceptions. When an unexpected error occurs, we can throw an exception that we expect will be caught elsewhere in the program. Throwing an exception is accomplished using a throw statement. Here is the syntax of that statement. It begins with the reserved word throw, followed by an exception object. The exception object is almost always an anonymous object, meaning that it has no name. Instead, it is typically instantiated in line, which means what we normally see is the reserved word new followed by a call to the constructor of the exception class that defines the kind of exception that we intend to throw. There is another similar reserved word in Java, which is throws. The introduction of this reserved word is another slight departure from the syntax of C++ that used the same word for both purposes. When a checked exception is not caught, it must be declared as thrown. The reserved word throws is what must be used to accomplish that declaration. It is used in a throws clause that is added to the end of a method signature. Here is the syntax of that throws clause. Notice that it is enclosed in the black square brackets that mean it is optional, which should be clear given the fact that we have seen method signatures already and none have included that clause. Next, let's examine an example of a class that throws an exception, the date class. Although Java has a predefined date class, we chose it as an example because date formats have many constraints that can create a need to throw exceptions. Note first that the instance variables have been declared protected. We made that choice in part to illustrate its use and because we intend to extend this class and want its subclass to have access to these instance variables. Let's begin by looking at the fromString method that is intended to perform the inverse operation of toString, which is to take a string and convert it to a date object. Unlike toString, fromString has no particular special significance in Java, nor is it universally used. But it is useful in conjunction with input, much like toString is with output. Notice that it uses the split method to break apart the string specifying slashes as the delimiters that separate the three components of a date, and then checks that split produced three strings corresponding to the month, day, and year, all written numerically. If the number of strings was anything other than 3, the system-defined exception illegal argument exception is thrown using the throw statement. Observe that it instantiates an anonymous exception object which it then throws. Because the illegal argument exception is an unchecked exception, the throws clause is not required. But it is still allowed and it is informative, so it is a good idea to include it. Scrolling down to the rest of the fromString method, provided that the original string split into 3 strings, each of those strings is then converted to an int using the parseInt method and stored into the corresponding field of the newly created date object. The toString method generates a string in the format where the month name is written first, followed by the day, a comma, and then the year. Now we examine how we can define custom exception classes. Both predefined and user-defined exceptions can be thrown. If a predefined exception exists that has a name that is descriptive of the error, then using an existing class may suffice. If, however, no predefined class exists, then we can define a custom class. When we elect to define an exception class of our own, we must make the choice of whether the exception is checked or unchecked. The basis for that decision is whether we expect the error to be one from which it is possible to recover. This decision can sometimes be a subjective one. If we decide on a checked exception, then our exception class must extend the predefined class exception. If we decide upon an unchecked exception, it should extend runtime exception. User-defined exceptions should never extend error. In many cases, an exception class may have an empty body, meaning it will contain no additional data or methods. User-defined exceptions can, however, carry some additional information. In that case, adding a constructor that accepts a string is often the approach that is used. The invalidDate class illustrates a custom-defined exception. Notice that we elected to make it unchecked, which is indicated by the fact that it extends runtime exception. The class includes only a constructor that allows a message to be supplied to clarify why the date is invalid. Next, let's consider the checkDate class. It is a subclass of the date class presented earlier. We will see that it makes two additional checks on the format of the date. Because checkDate is a subclass of date, date objects cannot be coerced to be objects of type checkDate, which is why we need this constructor that turns date objects into checkDate objects. Let's scroll down so we can examine the FromString method in this class. The call to the FromString method is placed inside a try block that can throw two exceptions. The first one that it catches is the number format exception that will be thrown by the call to parseInt in the FromString method in the date class if any of the three strings are not integers. When it catches that exception, it throws an invalidDate exception with an appropriate message. It also catches the illegal argument exception that can be thrown by the FromString method in the date class and throws an invalidDate exception with a different message. This class has two private methods. The first is checkRange. It is called in the try block of the FromString method. It checks that the month and day are within range. If either of them is out of range, it throws an invalidDate exception that contains an appropriate message. The check on the day range involves a call to another private method, isLeapDay. So let's scroll down to look at that final method. In determining whether a day is a leap day, we simplified the check for leap years, which is actually a bit more complicated. We conclude with a review of text file input and output, because file I/O can throw exceptions. We begin with input files. Input files are opened, creating a file object. Opening input files can cause a file not found exception to be thrown, which is a checked exception. It occurs when the file supplied does not exist, so it must either be caught or designated as thrown. The simplest approach is to then create a scanner object from the file object. Next, let's review file output. Output files are print writer objects. Unlike input files, output files are created, but there is still a remote chance that an exception could be thrown if for some reason a file could not be created. Both kinds of files should be explicitly closed. Most operating systems will do so automatically when the program exits, but it is best not to rely on that. The file scanner class is an example of a utility class, similar to the math class, meaning it contains no instance variables or methods. It contains only a class method. Notice that its default constructor is private, which prevents any objects from being instantiated. Let's scroll down so we can examine the bulk of the open file method. It prompts the user for a file name and attempts to open the file. If the file opens, it creates a scanner object for the file and returns it. Otherwise, it catches the file not found exception and reprompts the user for a different name. Now let's examine the validate dates class. It uses the file scanner class and the previously discussed classes in the dates package. Scrolling down to the rest of this method, it reads in dates from the input file and writes the valid dates to an output file and displays invalid dates on the console along with the reason that they are invalid. Notice one other aspect of this program. The try-catch statement includes a finally block, which is an optional part of the try-catch statement syntax that we did not previously mention. It is executed regardless of whether an exception is thrown. In this case, it ensures the input file is closed. Let's look at the input file that we are going to use, dates.txt. It contains some valid and some invalid dates. With NetBeans, the default directory for both input and output files is the directory above the source directory. Now let's run the program. First, let's enter an invalid file name. To show that we will be reprompted to enter a correct name. Next, let's enter a correct name. Notice that the invalid dates are displayed as output along with the reasons that they are invalid. Finally, let's open the output file to see that the valid dates have been included and translated to the format that includes the month name.